LEAD 2 is a follow-on to the LEAD project, which was a National Science Foundation, large-scale National Science Foundation project that went on, just ended in September and went on for a number of years. So LEAD 2 is cyber infrastructure in support of something called Vortex2. Vortex2 is a large-scale, basically a large-scale tornado chasing effort. It's a nomadic effort that every day for 6 weeks, from the 1st of May till the middle of June, gathers people and planes and cars and trucks in a direction in pursuit of bad weather for the days. You know, the whole point in doing this is to understand, you know, what causes tornadoes to create, with the whole idea of basically trying to increase the amount of time that it takes between understanding a tornado is going to hit and where it's going to hit, and give people warning so that they can evacuate. What we are doing in this regard is providing the weather products that will making that choice a more accurate choice. This is work that we're doing in collaboration with Oklahoma University, University of North Carolina, Chapel Hill, and Microsoft. So LEAD 2 is cyber infrastructure, and unlike LEAD 1, which is primarily a Linux-based platform, we're marrying the ease of the Windows tools, which scientists engage in Windows tools, particularly Excel, quite heavily, particularly the Trident Scientific Workflow Workbench, with the computational resources that we need, and those are primarily Windows HPC server machines, and we're also utilizing TeraGrid. So LEAD 2 works by providing a scientist a visual interface at a workstation using the Trident Scientific Workflow Workbench. Through that interface, the scientist will define a workflow, which is a set of computational tasks that are working together. When that gets submitted, and for Vortex2, we're doing this on a 1-hour schedule for 6 hours, starting at 6 a.m. and running through noon. That workflow will go out and it will bind to data sources. In other words, it'll go get the current weather data, and we get that from Unidata, which delivers the weather data across the country. We chug through the computation, chug through the weather forecast as quickly as we can. We put together visualizations, and then we deliver the content to the mobile phones for our collaborator who is going to basically be in the field with the Vortex2 team. What's exciting about this effort, in my mind, is the educational benefit that it brings to the students. Vortex2 is a real-world experience. We have a strict timeline on which this cyber infrastructure has to deliver. And this is something that students don't often get. Students often work in a vacuum in an academic setting. This gives students very much a real-world setting with very immediate and very visible impact. And in my mind, that's a tremendous educational experience.